Hello, physics students. This video is to help you with question number 2 from the section review on page 85. Let's begin by reading that question. It says that a roller coaster moves 85 meters horizontally, then travels 45 meters at an angle of 30 degrees above the horizontal. What is its displacement from its starting point? It also says to use graphical techniques, but we're going to calculate this using some trigonometry. So let's go ahead and make a drawing first. That's kind of a way of showing what we're given here. We're going to start out by drawing a line horizontally. And this is going to represent 85 meters. Doesn't tell us in what direction, so we can just choose an arbitrary direction. It then travels 45 meters at an angle of 30 degrees above the horizontal. So our horizontal line is going to continue this way. And it's going to go 45 meters this way. And this angle here is going to be 30 degrees. All right, so we've got 45 up here. And what we want to find here is its displacement from its starting point. And so our vector that we're trying to find will be this right here. Okay, so trigonometry only works when we have a right triangle. So the first thing we have to do is create a right triangle, and then we're going to find some of these components, and we're going to have to add some things together, and then we're going to be able to solve this problem. So let's begin by finding where that right triangle is. We're going to create a right triangle, and here it is right here. Okay, so let's begin by finding this side over here and finding that length of that side on the right triangle. Okay, let's remember our trigonometric ratios. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. So we'll just have that there for easy reference. All right. So here we know the length of the hypotenuse. We know that it's 45. We know the angle. So if we know the angle on the hypotenuse or any one of the sides, we can find the opposite side. So to find this side right here, we are going to use which trigonometric ratio? Notice that that side is opposite our angle. Okay, so we know the hypotenuse, we're looking for the opposite, and we can find the sine of 30. So we're going to use sine. Sine of theta equals the opposite over the hypotenuse. Okay, but we're solving for the opposite, so we can rearrange this just like we would any other equation. So we can multiply both sides by hypotenuse. So hypotenuse on this side. And we end up with opposite is equal to the sine of theta times the hypotenuse. Okay? So now we're going to substitute our numbers. Opposite is equal to sine of 30 times 45. So let's get out our calculator. All right. And let's put those numbers in here. Now the first thing I want to do is I want to check and make sure that this is not set in radians, because if it is, I'm going to get the wrong answer. So let's go ahead and check the mode, and notice that it is set in radians, so I'm going to have to go down here and then go over and then set that so that it's now in degrees. All right, so I'm going to turn that off, and now I can go ahead and find the sine of 30, which is 0.5, times 45 meters, which is my length. And that tells me that the length of that side is 22.5 meters. All right, so let's just go ahead and write that in up here. This is 22.5 meters. All right, now let's find this lower side. Okay, and we're going to do this exactly the same way, only this time we're going to use cosine because we're going to find the adjacent. All right, but we rearrange that exactly the same way. We're going to end up this time, though, with adjacent is equal to cosine of theta times hypotenuse. So that's going to be the cosine of 30 times 45. So using again my calculator, see if we can pop that little sucker up here again. Let's find the cosine of 30. And we're going to take that and multiply it times 45. And you can do this in one big long step if you like. I'm just showing it to you this way so that you can see what I'm doing. Okay, and that tells us the length of that side is 38.971143. Oh my goodness. Let's just go ahead and stick with 2 decimal places for now. We're going to round this off to significant figures when we're done. We want to leave a few extras just so we don't have as much rounding error. So 38.97, let's go ahead and use that as the length of the lower side of this triangle that we've created. So 38.97 meters. Now, in order to find the resultant, to find the red arrow, what I'm looking for, I'm going to have to find this total length here for one side of my triangle. Okay, so we've got 85 plus 38.97. Okay, putting that in the calculator, we get well, it helps when you turn it on. Let's just do it this way. 85 plus 38.97. 123.97. Let's go ahead and round that one to 124 at this point. All right. So this is 124. The other side of our triangle is 22.5. So we can use Pythagorean theorem now to find the length of that hypotenuse. So 124, let me use a pen here instead of a mouse. 124 squared plus 22.5 squared, Pythagorean theorem, a squared plus b squared equals c squared. Okay, 124 squared plus 22.5 squared. Now, that's not my answer because that gives me c squared. So I have to take the square root of that. So I take the square root of that number and I get 126. All right. So the magnitude of this vector is 126 meters. Now I still need to know this angle right here. Okay, but I can use the information I have here in order to find that angle. I can use any one of these sides in order to find that, or any couple of those sides. So let's go ahead and use tangent in order to find that angle. The tangent is equal to the opposite over the adjacent. Okay, the tangent of theta. Well, I know my opposite and I know my adjacent. The tangent of theta, which is what I'm looking for, is equal to the opposite, which is going to be 22.5. And my adjacent in this case is going to be 124 meters. So if you enter that into the calculator, 22.5 divided by 124. Okay. Now, that is the decimal equivalent of this ratio. And your calculator is able to tell you what that corresponds to in degrees. But what we're going to do is we're going to use that number. We're going to take the arctangent of that. We're actually going to divide by the tangent. So to find that key, look above where it says tangent. And you'll see it says tangent and then there's a -1 exponent there. That's going to give you the arctangent. And then we're going to insert that answer that we got. and it tells us that it's 10.2845 degrees. Again, let's do 3 significant figures. And so we are going to go with 10.3 degrees. Actually, looking at what we have, did we have 2 or 3 significant figures in this? Oh, we only had 2 significant figures. So we're just going to go with 10 degrees. So, in answer to this question, the displacement of the roller coaster from its starting point is 126 meters, 10 degrees north of east. And there you have it.